Hello, I'm Tope, and this is my Physics 2212 Lab 1, otherwise known as the Charged Tapes Lab. To introduce why this lab was conducted, it is important to introduce these few ideas. First, this lab was a good introduction to understanding the idea of a charge, as well as coding and modeling experimental data. Likewise, another key aspect of this lab was to utilize household objects to demonstrate such key physics principles such as charge, electric field, and Newton's first law. A few key other aspects of the lab that are important to mention include the utilization of charged tapes to demonstrate those principles that I mentioned earlier. Likewise, I was able to demonstrate using certain known parameters, tape length and distance, how to effectively find the charge on any two particular bodies. Likewise, it also demonstrated how to use computational tools to conduct calculations and discover properties of other objects. To actually conduct the lab, the following method was conducted. One tape was stuck to a table, and then two tapes were then ripped off of this tape. Likewise, after I ripped off those two tapes, I was able to create the setup as seen on the bottom right. Pulling one tape off of another induces a change in charge on both tapes. Likewise, I then utilized an experiment to find the charge of the tapes once they had been ripped off of the base tape. I also conducted some testing to describe some certain qualitative aspects about my tapes. Some key observations about my tapes are as follows. Two tapes repelled each other, which indicated that they both had the same direction of charge. Likewise, the tapes were attracted to a pen that was known to be negatively charged, which indicated that the tapes were positively charged. This meant that during the process of ripping, the tapes had lost electrons. Finally, it was discovered that tapes were slightly attracted to neutral objects, likely due to a polarization effect on those neutral objects. Some other key observations are as follows. If the U-tip had happened to be positively charged, the interaction with the pen would have been an attractive force. Likewise, if the U-tape was negatively charged, then the interaction with the pen would have been repulsive. Had the tape been neutral, there should have been no interaction with the pen, since it would have no charge and contribute to zero force via Coulomb's law. Likewise, after these assumptions were done, it was then found that the tape was positively charged since it attracted towards the pen, which indicated that the charge was positive because the pen was known to be negative. The following equation was conducted to find the actual mass, mass of my tape. Knowing that the linear density of a tape was 1 gram per meter, and knowing that my length of the tape was 7.5 inches, I was able to find the mass. Continuing, I conducted a free body diagram of my tape to actually find the charge of my tape. Utilizing the fact that there was no net movement or zero acceleration from the tape, it meant that it indicated that the gravitational force on pushing down on the tape was equal to the repulsive force from the lower tape. Since all other quantities, including Coulomb's constant, distance, as well as the gravitational force were known, I was able to find the charge of one tape. The charge of one tape was found to be 6.44 times 10 to the negative 7 coulombs, indicating that it was positively charged. Nonetheless, this quantity represents the total charge of one tape, and utilizing the fact that one electron has a charge of negative 1.6 times 10 to the negative 19, I was able to find the total number of deficient electrons on the tape. Once again, continuing, once I had found the number of deficient electrons, I was able to find the respective ratio of deficient electrons to the total number of atoms on my tape, using the formula represented on the screen. Since I knew that the area of one atom had to be 10 times 10 to the negative 10 meters squared, I was able to find this ratio. After the experiment was conducted, it's important to mention some key assumptions. Experimentally, it was assumed that charges were isolated to the middle of the tape. However, they were present across the tape, indicating that there must have been an interaction with all of those other charges on the other tape. Likewise, there's no guarantee that these two tapes had the same charge, and this assumption was key to actually finding the charge of the tape. Nonetheless, touching the two tapes inherently disrupts the interaction because touching the tapes allows electrons to flow from between your hand towards the tape. Some calculatory assumptions were also described on the screen. To conclude, it's important to answer these two questions. If the electrons had positive charge and protons had negative charge, what would have changed about my observations with regards to the tape and other objects? The answer to this question is that not much would have changed. If all of the charges had been flipped, forces that would have been attractive forces previously would still continue to be attractive forces, and the same is true for repulsive forces. Why is it important to handle the charged tapes as little as possible? Handling these charged tapes allows electrons to flow from between your hands to these tapes, and this is also true when the tapes are in contact with other objects. This reduces the charge magnitude on the tapes and therefore will provide less experimental power. Finally, to conclude, here are a few key aspects of this lab that are important to mention. Charges are a relevant factor to everyday interactions that govern our world, at least from a physical standpoint. Likewise, it's important to utilize experimental modeling and computation to extract information, as well as the fact that Newton's laws are relevant and important. To conclude, here is a quick snapshot of the computational model that I utilized to actually describe the behavior of those two charges and the forces present on the upper tape. Thank you.